Hi, everyone. It is February 13th. That means um, we are in our second week of Phenotype February. Tomorrow is Valentine's Day. The last 2 years on Valentine's Day, we usually we talk about heart conditions. It was a complete coincidence. This year, though, our Valentine's Day week and day will be about lung cancer, where Asieh is going to lead us into the work that the community has already accomplished for lung cancer. Just a reminder of what we completed for Alzheimer for last week, the few things that happened after our community call last week. So we replicated all the Alzheimer definitions that we found in the recent literature. We ran cohort diagnostics on those. On last Friday, we had a call where we reviewed some of those cohort diagnostics results. As well, Patrick went through a demo of how he replicated two of these definitions, or actually three of those definitions. So if you missed that call, it was an excellent Atlas demo. Though if you're interested in knowing more about Atlas and how to work with vocabulary and source code and standard, that was a really great demo to look at. And it's where Craig already shared with us where he put all these recordings. Okay, that completed the Alzheimer work, and I'll talk a little bit about some of our main findings. Now Asieh and the group kicked the work on lung cancer at the end of last week. As of today, the literature review abstraction has been completed, and Asieh is going to talk about their finding, and the next step will be replicating those cohort definitions, which you will see a post about if you want to contribute into replicating some of those definitions that Asieh and the group has identified. For MDD, Anna already circulated the literature review task sheet with only last night, and she told me this morning that it's already completed for sign up. So sorry, volunteers, all the thoughts have been taken for MDD, but we have another list coming for pulmonary arterial hypertension at the end of this week. So amazing work, and thank you, Anna, for leading that. Okay. So a final note on Alzheimer, what we found when we looked at phenotype definition, replicated them across a network of data in OMAP, and what we have found in terms of characteristics of patients and how these things varied by definition. Overall, we replicated about 11 definitions. We found that the incidence rate of Alzheimer in the databases we replicated the definition on varied significantly depending on the definition you use, and that's somehow expected. We quantify that by about in some databases between different definitions, the incidence rate of Alzheimer changed up to 6-fold depending on the definition used, and that was across the data sources. And that, of course, highlight how the choice of the definition can affect study results, given that the frequency of the events is usually one of the parameters that affect the findings of any observational study. We also found that the overlap between subjects identified using different algorithms for Alzheimer vary. The overlap was as little as 5%. So there's only 5% common population that was identified between two definitions, for example. It could also be up to 70%. So in some cases, the overlap was good, but in many cases were poor, average about 20 to 40% and range from 5 to 70%, depending on the definition used. And of course, that highlight the heterogeneity, that not only the occurrence of the event varied, but also who we are capturing depending on the definition varied. One of the good findings, though, is that even though the incidence varied and the overlap was sometimes very little, however, the demographic composition of who end up being classified as having Alzheimer was actually consistent across these definitions. We found, for example, that usually made at a higher rate, and that was consistent across all the definitions. We also, the age distribution of people who get Alzheimer's seem to be similar, so similar to or consistent with what we accept, with a higher proportion among those who are 80 and above. So that was a good sign. However, again, the overlap and the incidence rate varied significantly. Another finding was related to the proportion of Alzheimer within the ADRD population. We talked last week about the ADRD population and how it is a more broader idea that dominated the observational studies in the last 4 years, as opposed to focus on only specific diagnosis of Alzheimer. What we found is inconsistent with what we expected. Those Alzheimer disease population only compose about 5 to 20% of the overall ADRD population. And those diagnoses of specific Alzheimer disease was only as little as 5% up to 20%, which is not consistent with what we clinically expect, given that Alzheimer disease is supposed to be the most dominant type of dementia. But that's not something we saw or manifested in the data. That could be either an underdiagnosis of Alzheimer in our systems, or it could be a result of some misclassification or a measurement error related to the definitions of ADRD or Alzheimer itself. Another finding was that there was a clear misclassification of the index date of when we classify people as having Alzheimer. One observation was consistent across all the data sources and across all the different definitions, is that we found that there's a good proportion of people, sometimes up to 20% of the people with Alzheimer starting the treatment before they're actually indexed on having Alzheimer. And there's also a big proportion of people having ADRD before they classified as having Alzheimer. So again, when the person satisfied this definition of Alzheimer, could be another source of error in observational data. And also in clinical practice, because we know that the diagnosis of Alzheimer is not easy, and maybe what we're observing in the data is just a reflection of how uncertain a clinician is to diagnose somebody with Alzheimer, and maybe that comes later in the journey of the disease itself, and maybe people start on treatment before they get a final diagnosis. Finally, across all these different definitions, just from an informatics and data perspective, we saw that definitions are dominantly using the diagnosis or condition as a way to define people as having Alzheimer. However, other domains of data were also used, such as drug exposures, and also the care setting, changing the definition depending on the visit type, and sometimes requiring a certain provider, type of provider or specialty to be associated with the diagnosis. But overall, diagnosis codes were the main requirement of these definitions, and some use drug exposures and a type of visit or specialty. But those across these, how definitions use these different domains of data represent the main variation in these definitions. That's all for Alzheimer. Finally, this is our Phe-evaluated results for a set of the definition we use. And I'm not going to go over the numbers, but sensitivity and PPV as estimated by a Phe-evaluated for the different definitions really overlap with those reported in the literature and what I showed you last week. Phe-evaluator did favor a definition that is really only based on diagnosis without so much other requirements. But overall, we see that the sensitivity range somewhere between as low as 50% up to 70%, with the PPV being on a higher scale, going from somewhere 70% to 90%, which is also roughly these directionally also consistent with the literature. Maybe Phe-evaluator is estimating a higher PPV than reported, but overall it's in the same direction. Okay, that's everything we learned about Alzheimer phenotypes for now, and I will move it to Asieh to talk about lung cancer. Oops. You want to share your screen or?
Yes.
Yes. Okay,
I will
perfect.
do that. So, hi everyone, and I didn't know I'm gonna be doing something close to Valentine's Day. I hope lung cancer satisfies a good, fun phenotype. So, happy Valentine's Day in advance. So before I start, I want to actually thank everyone who has helped and jumped the very, very last minute when I sent the note on Saturday evening or afternoon. I did not expect people would volunteer. I thought, oh my God, I'm going to do the whole thing myself because I'm too late. but really, really appreciate everyone who jumped in and helped. Beta, Fanny, Bucci, Steve, Coco, Alexi, Lingyin, Harold, Jessica, and Christian. I couldn't do it without you guys and everybody else who's helped so far. So thank you so much. So let me get started. And while I'm sharing this screen, I want to actually tell you a little bit of a story. I'm not going to see you, but let me know if you can see the screen. I only have 2 slides, and then I will show you some other stuff.
We can see it.
Wonderful. So 2 years ago, around the same time, actually, end of February 22nd, I also volunteered to create a phenotype for non-small cell lung cancer. A bunch of us got together to discuss how we're going to do that. Going through the entire process of defining the description, going through the literature review, and critically appraise some of the literature and come up with 1 or 2 recommendations. We had the conversation. It was a very, very interesting and heated conversation within the group, and we came with some sort of report on like what did we find and what do we want to do. And very specifically, there was conversation along, okay, it's a disease, but it's not lung cancer. I can't find it in specific data. You guys have probably heard me complain a lot about how we should all convert our data to oncology so we can properly phenotype non-small cell lung cancer or any other cancers that involve or require specific information that is not available as standardized data. We discuss some of the approaches and limitations or limitations of the data and some of the nuances or some of the limitations that we would have or potential implications of some of the assumptions. Do we use treatment or what as a proxy for the disease? What are the implications? What not? What if we know that a lot of people are not being treated or the treatment is changing and all that? So at the end of that exercise, we decided, okay, we can actually try and build some of these and investigate and see what are the potential differences and what's the impact of doing some of these approaches. Fast forward a couple months back, we actually looked at it in one of the databases that we had access to. So we created a couple of, and we tried to test one of those assumptions and the potential implications of that, which was basically using treatment as a proxy to define the 2 diseases. So remember, or for those of you who might be new, is lung cancer is an umbrella of all these like little tiny cancers that happen within an organ called lung. And they're usually described, sorry, Craig, go ahead. Described as a combination of what is the histology of the tumor and the location it's being, that is observed. What we see in a lot of the data is not that level of details. We see lung cancer, right? Then it gets to a frustration that I want to study that. What should I do? How do I differentiate non-small cell from small cell, squamous cell from adeno? So there are a lot of like approaches, like the whole phenotyping and what researcher does, like let me use treatment, right? So treatment information as a proxy because I know people are being treated differently. That's what we tested. We looked at treatment-specific information, and also we had within that specific database, it was an oncology database, we also had information on histology so we could test it out. And we were able to show that using that assumption can actually lead to huge misspecification of the patients, not identifying a huge bunch and then misidentifying the other ones. That was like a result that we showcased 2 years ago in the Odyssey community. Fast forward, we got to here. Again, based on the community vote, lung cancer is quite important. This time we decided that, okay, let's deep dive into non-small cell and small cell lung cancer. Only past four years and see what has research done, what do we want to replicate, and what do we find. So we started with the literature review, the whole string search, and we were able to identify 185 manuscripts that were published in the past 4 years, focused on either non-small cell or small cell lung cancer. We did a review of title and abstract, and also a quick review or scan of the full text and supplement. And We excluded 145 of them because of the following reasons. There was no text. It was a study talking about lung cancer, no distinction. That was not the goal of this exercise. Or there was no detail, like, or we just identified non-small cell lung cancer. How unclear. Or it was some sort of probabilistic phenotyping extremely advanced that we decided not to include it for this round. Ended up at 40, 45, like 5 of the one that you see, like we later excluded, that had enough information for extraction, and people jumped in and contributed for the extraction. 40 papers with some level of information on the phenotypes. Just to give you a breakdown of like the type of data that we're looking at, the majority of them are coming from databases that are linked, cancer registry with administrative claims. Pretty much the majority of the studies that we found use SEER Medicare data, SEER data linked with Medicare. So you get some benefits and beauty of cancer registry and the greatness of claims data, so you can actually answer a lot of different questions. 3 other sort of like linked databases. And then we see some usual suspects of administrative claims, Truven Markets, Pharmetrics, Optum, and some oncology EMR or EMR, very specific EMR data that have been used. So we have a very, very nice mix. I'm going to give you a summary. The biggest summary I can say is that, like, looking at the 40 extraction information I'll show you is just a big mess. But what is quite clear from that, what we've done so far, is that these phenotypes that we see here are way more complex than a sheer condition. We can't see something called non-small cell lung cancer or small cell lung cancer. Usually the phenotype that has been developed for any of these studies is a sort of a combination of any of these conditions with additional requirement. It's an advanced disease or stage 3 with tumor that is more than between 5 and 7 centimeters. Tumors, non-small cell lung cancer that have ALK, are ALK positive or are being treated with immune checkpoint inhibitors or crizotinib as a second line after that. So all of a sudden, we're looking at non-comparable phenotypes that are not small cell or non-small cell. If you want to extract the piece on the disease like itself, non-small cell, or like I'm just going to talk about non-small cell to keep it focused, we see that every single researcher is actually using a different code list, or what we call concept set. Even those that are using the same terminology, say ICDO, what we are recommending in the oncology work group as the terminology for representing conditions in oncology, people are using it differently. It's all over the place. Very, very like, it's not surprising that it's heavily dependent on the database. Like, what database is it, like a cancer registry, is it claims, or is it an oncology EMR or not? Also the timing. When the stage 3B used to be an advanced, locally advanced disease, and when it was not pre-2018 or after 2018. Some people are using very broad information that lacks histology, and then exactly, so ICDO if you have registry. And as I said, like, there is a time coverage for pretty much all of the phenotypes that's been developed, wash up and follow up period. Some of them have expiration dates, and some of them has passed their expiration date. And usually there is a purpose. We observe like 5 or 6 different themes, or purpose is for doing treatment description of the treatment utilization or economic burden, or describing patient characteristics that sort of dictate what are these, like, the logics or like the additional criteria should be and how it's going to be used. And theoretically, there was no one paper that only described a disease that is called non-small cell lung cancer or small cell lung cancer. But what I want to do now is to show you just a snapshot of how it looks like, because I need your help to decide what would be next step. So give me 1 second. Okay, this is the beauty that we've created together, like from the conditions, phenotype, and everything. And yesterday when we were talking with Azza and Anna and everybody else in Gotham, I was like, okay, like, let's just clean it up. We'll identify the ones that we can actually phenotype, and then we'll continue. And I spent quite a lot of time cleaning it. So I had to clean the name of the database and the type. And I added a few other columns, just specifically these three, so that to show you what's happening and then to come up with a decision, just to let you know what the situation is. So as you see, like just looking at the components of the phenotype that is focused on non-small cell lung cancer or small cell lung cancer, you see a huge mix of some people don't even say what they use. They use a combination of only talk about histology. Some people say histology with behavior. Not everyone likes to identify behavior. Is it malignant or not? Do we include in situ or not? Some people say where the topology or anatomy of the tumors is. Some people don't actually care. And there are ICD-9, 10, or a combination of that. And there's like this ginormous additional criteria that is biomarker information, stage information, treatment, other conditions, other drugs. So just to show you how these things are, this is like a very, very dirty pivot table, but like, as you can see, like these are all each line is one phenotype. So even for those folks who have used ICD-9 or 10 or ICD-9, there is zero similarities and it's completely all over the place. Some of them and have like completely different time frames when it's been looked at. And then, and just like categorizing the purpose, we're looking at like these, like all the like healthcare utilization, economic burden, and so on and so forth. What was extremely annoying for me as a person, because I really love to push oncology and we think ICDO are great, is that even for papers that are looking at ICDO that are using the same database, they're not using the same codes. And these codes should come from like a higher authority that we think it's true, but some people decide to use them and not to use them. And I can actually show it to you here. Like it's quite easy to look at SEER Medicare. And the set of codes that you see, for example, here and here are not exactly the same. And that happens quite, like I went through all of the ICDO and they do not agree. So not want to talk a lot. I just wanted to show you all this with one question for all of you. We have 40 phenotypes that are completely different. We have the codes. Some of the codes you see here, some of them are 5 to 10 pages of procedure codes, drug codes, and timeframes to be able to identify them. Some of them are based on the assumptions that the specific patients are using it, and they're actually like their usability is expired. For example, the advanced non-small cell lung cancer patients treated with ICI, using ICI or immune checkpoint inhibitor as a potential way to identify them, that is lost. You can't use it. Immune checkpoint inhibitor are using at earlier stages, and they're also being used for small cell lung cancer, just an example. So tell me or tell us which one should we do and which phenotype should we build, because to be honest, I don't know. This is complicated, and I really want to build something that we can use and we can actually benefit from. Let's open for conversation. I have 3 minutes, but that was it.
If anybody has any thoughts, I know there's one question from Cynthia in the chat. Does ECOG have a uniform phenotype for non-small cell lung cancer? I don't know if you want to take that, but if there's any other questions, people can raise their hand. Otherwise, I assume are these conversations that will continue throughout the week in the work group calls?
Yeah, so
Okay.
we will be very busy the next 2 days trying to make sense of all those findings and try to see what makes sense to replicate. Of course, we have different data sources and different partner. Speaking out of claims, we're going to try to replicate the ones that are applicable for claims, and there's only few of them, obviously. But these data partners who have access to registries, cancer registry, their participation going to be instrumental in lung cancer, because a lot of this data exists actually in those sorts of data. So we will follow up with Asieh in how we're going to see which we can replicate and dig deeper into the replication process, which will be very busy in the next 2 days. JB?
Yep, go ahead.
I just want to basically thank you all so far for going through this today. Asieh, that was very, very deep dive. Appreciate it. But I just want to comment on what Gautam wrote in the meeting chat, that we're basically near the very end of developing the Phenotype February 2024 study package. So if you are a data holder and would like to run these cohort diagnostics and incidence rates on your own study data and share those results back, please indicate that by navigating to the link that Gautam shared. And in the very near future, we'll have a study package for you to run on your own data. It's just undergoing the last round of testing at the moment, and once that is cleared, I'll distribute it to you all that would like to run on your own data.
And obviously, that's currently include only the Alzheimer cohorts. End of this week, we'll figure out what the lung cancer cohort's going to look like, and then we'll keep adding as we progress. Okay, very last minute, next steps. So next 2 days, lung cancer replication. We'll post something on the forum for people who would need help. Study package, please, if you are a data partner who have access to patient level data and have interest in running cohort diagnostics or incidence rate, please fill in the form that Gautam just shared so we can get to you. We're going to have an open call talk to plan the manuscripts. So that's another call that's coming in. And then Anna is leading the replication, the literature abstraction for the MDD. Pay attention to that if you already sign up for volunteering. And the list for arterial hypertension is also following at the end of this week.